Hey, this is Mr. Mason, and what we're going to do in this tutorial is we're going to practice solving systems of equations using the elimination method. Now, what we have here are two equations, and these equations are linear equations, so we could graph these on the coordinate plane. Now, if we were to graph these on the coordinate plane, they would intersect at a very specific point, and that point would be the solution to this system of equations. Now, what that really means is there is a single x and a single y that if you were to plug those values into both of these equations, they would result in a true statement for each one of these equations. So to figure out what this is, what we're going to have to do is first eliminate just the x's and solve for the y, or eliminate the y's and solve for just the x's. And that's what elimination really is. It's the process of getting only one variable in your equation so you can solve for that variable. Like if we were to solve or try to solve this equation, we couldn't solve it because we have an x and a y in the equation. We would have to know what one or the other is so we could solve for the other. So let's go ahead and get started. So the first thing that we need to do is make sure that either the x terms in both equations are opposite or the y terms are opposite. Now by opposite, I don't just mean the signs like positive and negative. I mean like positive 6 and negative 6, or positive 12 and negative 12. Now, right now we have a positive 6 and a negative 1 for the x values, and we have a negative 12 and a negative 6 for the coefficients of y. And we have to make sure that either the x coefficients or the y coefficients are opposite of each other. Now, as it stands, neither of them are opposite, so we have to force the issue. So what we have to do is this. We either have to make this negative 1 into a negative 6, because that would be opposite of positive 6, or we could turn this negative 6 here into a positive 12, which is the opposite of negative 12. So there's a few options when you solve systems of equations. So here's what I like to do. I'm going to start by changing this negative 1x into a negative 6x. So here is how we're going to accomplish that. The first thing that you have to do is you group everything on the left-hand side and everything on the right-hand side. And then what you do is you take the term that you want to make opposite of the corresponding term in the other equation. I want to make this negative 1 a negative 6. So you have to figure, what would you multiply this coefficient by to make it a negative 6? And the only thing that is possible is multiplying it by positive 6, because 6 times negative 1 is negative 6. Now, we have to multiply that 6, though, by every other term in the entire equation, on the left-hand side of the equation and the right as well. So I'm going to write a 6 on the outside of these parentheses to show balance. So now what we're going to do is take 6 and distribute it to both terms in here. So 6 times negative 1x is negative 6x. And 6 times negative 6y is negative 36y. And 4 times 6 is equal to 24. All right. What we're going to do now is we're going to take this first equation up here, and I'm just going to line it up with our new equation. But understand this new equation is still equivalent to this equation. We just proportionally increased everything on the left and the right. However, it still has the same value as the original equation. So let's take 6x minus 12y equals 24. All right, now we have a situation where the x terms are complete opposite of each other. And because they are opposite of each other, we can eliminate them, because opposite terms have a result of 0. So they don't exist anymore. We can get rid of those terms. So what we do now is we vertically add up these y terms here. So when we combine negative 36y and negative 12y, that would be a total of negative 48y. And we set that equal to the total of these constants right here. 24 plus 24 is 48. All right, now we can use a little bit of mental math to see that the only thing we can multiply negative 48 by to make positive 48 would be positive 1. But let's just show our work the proper way. We're going to divide negative 48 by itself. And anything divided by itself is always positive 1. That leaves us with positive 1y. And we balance our equation by dividing that side by negative 48 as well. 48 divided by negative 48 is equal to negative 1. Now, we know what y is equal to now, and we're going to use that information to figure out what the x value should be. Now, to do that, we select one of our two original equations. I'm just going to go ahead and select the first one. 6x minus 12y is equal to 24. And we take our known y value and we substitute it in for y. So we rewrite this as 6x minus 12 multiplied by negative 1 is equal to 24. And now we can solve for the value of x. So let's simplify this a bit. We can rewrite this as 6x plus 12. Notice we have a negative multiplied by a negative, which results in a positive, equals 24. Next, we take this constant, which is positive 12, and move it to the other side. That would be negative 12. And 24 minus 12 is 12. And that leaves us with 6 times x. And now we divide both sides by our coefficient of 6. So that leaves us with x is equal to 2. So now we know that the solution for our system is x equals 2 and y equals negative 1. And it is quite frequent that you see your answer expressed as an ordered pair. So these would be the coordinates to where the two lines represented by these two equations would intersect each other. The x value is positive 2 and the y value is negative 1. Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and enable notifications so you can be informed as I upload new math tutorials to my math channel. Until next time, this is Shane Masonette with Masonette Math.